If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture on gate measurement series. So today we'll be solving question number 41, 42, 43, 44 and then 45. Okay, then let's try to solve these questions. Now if you come to 41, the effect of stray magnetic field in actuating torque of a portable instrument is maximum when the operating field of the instrument and the stray field are. So when it will be maximum? The torque you want to maximize the torque, so you increase the magnetic field flux. So it should be, if it is in the same line at where the normal flux was flowing in the meter, the extra flux that is coming, then it will be adding that flux. So if flux added, then torque will be maximized. So it should be in parallel. Parallel means it is coming in line with this one. If it is coming against this one, then it will decrease the magnetic field while torque will be reduced. If it is flowing along the magnetic field, so torque will be increased. So B, that is B will be added, so that's why it will be parallel. 41 is B. Now if you come to 42, a DC voltage with ripple, this is given. The measurement of this voltage made by moving coil and moving iron. Moving coil, so many questions we have done. Moving coil means you can think of PMMC, permanent magnet moving coil, and moving iron. So this will give only DC value and this will give you RMS value. So what is the DC value of this one? 100. So V1 will read simply 100. And what is V2? V2 is the moving iron, so it will give RMS value. So what is the RMS value of this one? We have already solved so many questions. RMS of first one, RMS of second one, and RMS of third one. So all this square then divided by 2. All this square then under root. So if you take this is 100.312. So what is the difference between these two? 0.312. So this is your answer. This is done, we have done in so many times. It is PMMC, so it is DC, and it is MI, so it is RMS value. A 0 to 1 ampere moving iron ammeter has an internal resistance of this 50 milliohm and an inductance of this. The shunt coil is connected to extend its range from 0 to 10 ampere for all operating frequencies. Okay. So this is my meter. So my meter has a resistance and a inductance also. So I am connecting some shunt. So my shunt will also have same type of impedance. Just values will change. So what was this value? This is 50 milliohm, and then it is XL, if you take, it is 2 pi into 0.1 milli into frequency F, whatever. Okay, so what is your current? This current is 1 ampere. You want to extend it for 10 amperes. So what should be the current? 9 ampere here. When you flow 10 ampere, it cannot go maximum. 1 ampere is maximum, so rest current will flow through. So the ratio is 1:9. So everything will be divided by 9. So this resistance will also divide by 9. Now what they are asking, the time constant and resistance in milliohm for the shunt coil is. So what will be the resistance? 9 milli divide 50 milli divided by 9, which is around 5.5 milliohm. So this is one question. That will be the resistance in the shunt coil, that is 5.55. That is your option A. You can easily see it is option A. But if you want to calculate the time constant of millisecond and resistance of the shunt coil, the time constant, because everything will, R will be divided by 9, L will be also divided by 9. So what is time constant? Omega L by R. So because L also you are dividing 9, R also, so the time constant of these two remains same. Whatever the time constant is, this one same time constant. Or you can think it L by 9 and omega by 9. So it is omega L by R. 9 is gone because both are divided by this one. So you put it there. If you put it there, then it is, time constant L by R, no omega. So it is, what is L? L is 0.1 into 10 to the power minus 3 divided by R is equal to how much? 50 milli. And here it will be, both will be divided by 0.99. If they ask you what will be the L of this coil, shunt coil, it will be also divided by 9. So if you solve it, you will find it is 2 milliseconds. So that's why it is option A. Now in 44, a DC potentiometer measured is in DC potentiometer measurement, the second reading is often taken. If you done experiment, then you must have done it in potentiometer by reversing the DC polarity of the unknown voltage. The average of the two readings, this is done to eliminate, because in potentiometer there will be junctions of metal, and in the metal junctions there is thermo EMF that is generated. So if you reverse the polarity, so that error will be in reverse direction, and then if you add it, that get cancelled and you get the exact value. So that's why it is nothing but the stray thermal EMF. And in DC potentiometer you are using your hand also to change that knob, but that also comes into effect. So this all gives rise to stray thermal EMF, and that due to which, to nullify that one, you connect it in reverse order, so that the error whatever you got it In reverse order, if you connect it, the thermo EMF will be generated in reverse order, so that will be in negative. So if you finally, when you for average, if you add these two, it will get cancelled out. So it is due to the straight thermal EMF. A DC potentiometer is designed to measure up to 2 volt with a slide wire of this. A standard cell of 1.18 obtains a balance at 600. The test cell is obtained at 680 balance. Then what is it? It is simple unitary method. If for 600 millimeter means up to, if increase this length means this drop is up, whatever the resistance of 600 millimeter, that drop becomes equal to your supply voltage, that is 1.1. That's why it is balanced there. Similarly, if you go 680, it will be automatically increase that one. So it is simple linear relation. If for 600 the resistance is whatever resistance, that IR drop is 1.18. For 680 it will be linear. For 1 it will be this by this, and for 680 it will be multiplied by 680. So if you do this one, I think you will get 1.34. That is your answer. If you like the video, then press the like button and please give your valuable comments in the comment section.